So the problem on the board is t plus v, the square of that is equal to 289. TV is equal to 30. There's two ways to do this problem, and because it's an ACT type problem, you want to go with the way that allows you to finish quickly. All you do at this point is you realize that you can take the square root of both sides, and so you get t plus v is equal to the square root of 289, which is 17. So t plus v is equal to 17. However, tv is equal to 30. And so using substitution, you can solve this problem to the end. What I want to focus on right now is the long method. I want to explain something that is interesting here, okay? This is how we handle the problem with the long method. You have two equations. What I did when I was trying to do the long method was I chose to use a foiling, if you understand what I mean, like foiling these two. But before I did that, I substituted a value in there. So let's take our t. T is equal to 30 over v. So 30 over v is now going to represent t every time I see it. So if this is my new t, that means back here, I'm going to have 30 over v plus v squared is equal to 289. At this point, the next thing I want to do is to write out the two brackets. We have 30 over v plus v, 30 over v plus v is equal to 289. Again, this is a very long method. You don't have to do it, but I just want to use it as an example to teach you how to do complex quadratic equations. So 30 over v plus v and then 30 over v plus v is equal to 289. We'll go ahead and multiply our terms. So we have 30 over v times 30 over v, which is 900 over v squared, plus 30 over v times v, plus v times 30 over v, plus v squared. The v's cancel because there's a multiplication that connects them, and the only thing we have left is 900 over v squared plus 30 plus 30, which is 60, plus v squared is equal to 289. The next step is I don't want to deal with the v squared, and I'm going to do something with it in a second. But before I do that, I want you to go back again and see. The first step, we did that, we foiled, we got that answer. The next step now, we're at this point. I hope it's beginning to make sense. I'm going to continue with the final step. All you want to do is you want to put this so that it becomes like a quadratic equation. When you look at the v squared there, that should ring a bell on how to do problems like this. And so all we're going to do is we're going to multiply everything by v squared so that we can get rid of the v squared on the bottom over there. So now we have 900 plus 60v squared plus v to the fourth power is equal to 289. The next thing we have is we're going to bring the 289 to the left side. So we subtract 289 from the right and 289 from the left. Well, sorry, the v squared also multiplied that. So we have 289v squared. That's what we're subtracting from both sides. And at this point, all we would have is v to the fourth. I'm going to come back here and write it. V to the fourth plus 60v squared minus 289v squared plus 900 is equal to 0. And you simplify that, that would simply become v to the fourth minus 229 v squared plus 900 is equal to 0. This will most likely be an extra credit question on Thursday's quiz for both classes. And so what happens is, this is a quadratic equation. However, we have v to the fourth, and we have to simplify that. We have to break it down so that we have it in squared. And the way to do that is we're going to say, let v squared represent b. So if v squared represents b, then v to the fourth would be the same thing as b squared here. Minus, and then 229b. Because b now represents v squared. And that's plus 900, and that's equal to 0. At this point, what we do is we go ahead and use a as 1, b as negative 229, and our c as 900. and we plug that into a quadratic equation, quadratic formula, minus b plus or minus the square root of b squared minus 4ac over 2a. We plug in our a, our b, and our c, and we'll come to realize that we have b is equal to 225 or b is equal to 4. However, we established that v squared was equal to b. So what we're saying is v squared is equal to 225 or v squared is equal to 4. So v would be equal to 15 or v would be equal to 2. If you took v as 15 and you plugged it back into your expression here, that means t times 15 is equal to 30. So t is equal to 2. If you took v is equal to 2 and you plugged it in here, it will be t times 2 is equal to 30, so t will be equal to 15. What I'm saying is it doesn't matter. Whether v is 2 or v is 15 is not the point. The point is the question wants you then to write the value of t squared plus v squared. And the value of t squared plus v squared would ultimately be 15 squared plus 2 squared, or 2 squared plus 15 squared, which is the same answer. We have 289. And that's all you need to do at this point. Well, sorry, 229. Because you have 225 plus 4, or 4 plus 225. It's the same thing. This is a question you should be able to do using the long method, and so I would expect you to be able to handle it when you see it on Thursday.